Hey everyone, it's Ben from Board to Bits, and in this video we're going to be covering serializing your data in Unity into your own custom files. So this video is going to focus a lot on the idea of the binary formatter, which is this object that serializes and deserializes an object or an entire graph of connected objects in binary format. So basically you're going to be taking your classes in Unity and you're going to be converting them and putting them into a binary file for storage. This is going to store your files into this separate file outside of Unity, kind of like what we did in the XML video. However, don't feel like you have to watch the XML video to understand this one. However, I may from time to time kind of reference that one in comparing and contrasting these two processes because they're a little bit similar, but also have some important differences. So the pros of using this custom data file format are, first off, that it's very versatile. You're basically starting from scratch with this process, so you can do whatever you want with the data as you are saving and loading it. Secondly, it's the most secure system for storing your data, and by this I mean that you're making your own file type. It's a binary file type, so it's not like a text file that someone's going to be able to open and mess around with. If someone really wants to get down to breaking it down to the binary code, they can, and they could, in theory, build out what you're doing from there, but it's a highly unlikely scenario. So it's, like I said, it's a lot more difficult for someone to just kind of open and modify this file for you. Some of the cons, first off, you are starting from scratch, so this is going to take the most coding to set up. You have to build pretty much every function yourself, but this is kind of a benefit too, because you are, like I say, going to be able to do what you want with those functions, and we'll take a look at that in the example project in a few minutes. Another con is that if you do want modders to be able to modify data, this probably isn't the best solution because it's going to be very opaque to them. They're not going to be able to get into this file to change anything. The last con is that there can be some gotchas in terms of Unity-specific structs or classes that you're not going to be able to serialize. A lot of Unity's specific objects, things like vector 3s, quaternions, animation curves, even colors, aren't marked as serializable, so you have to find another way to serialize those. And again, it's definitely doable. You can, for example, take a vector 3 and just convert that into a array of 3 floats and store it that way, and then just convert it back. But it is a little bit extra legwork that you have to do in those cases. So what are custom files good for? They're really good for saving player gameplay. This is probably the top reason I've found to save these. Things like, if your player's save game is exactly what you're going to want to do with this. You're going to save it into a persistent data file path, and that's going to create this save file that players can actually see and they could share with each other, but they can't modify it, so it's good in that way. The other thing that this is good for is game component data that you want to have in a file. You don't necessarily want to keep it in a serialized object asset in your program or in your project, but you don't want it to be altered either. So you don't want modders getting in there and changing, some of your core content. You don't want that getting changed. Store it in one of these custom files versus using, say, the XML files that we talked about in a previous video. So how this works is it's pretty actually simple when you get right down to it. Basically, you're going to create this binary formatter, and it's going to read public variables in one of your classes. Bear in mind, again, it can't read things like sprites and like colors and things like that, but it can read a lot of other stuff, and basically it can read entire classes that you create. As long as you make those classes serializable, it'll be able to read them. So really what you do is you create a serializable data class with public data, and then you initialize a binary formatter, and then you just open or create a file for that binary formatter to write to, and it will create that file for you or read from that file and put things back into your classes for you. So now that we've talked about all that, let's jump into Unity and show an example of how all this works. Okay, so here we have yet another kind of simple game setup. In this case, we've got our player shown here using some UI elements. You don't really have to worry about those. Basically, what's important is that you've got a player that has 4 public ints. It's going to have a level, a health value, an attack value, and a defense value. If I open this up in MonoDevelop, we can see all this here. Public class player, it's a mono behavior, and then those 4 public ints. I've got a bunch of other functions down here, but these are really just for using with the player display class that I have. You don't really have to worry about those if you're following along with this. You can actually do all of this just as well by having, wherever you have your player game object, you can also see these values right here in the inspector. So you don't have to worry about the UI. It's just going to make it a little bit clearer when I'm playing the game. So now that we have this information, we need some way that we want to save and load this information. So what I'm going to do is I'm going to create another C# script. I'm going to call this Save Load Manager. I'm going to open that up in MonoDevelop. And we are going to delete MonoBehavior from this, and we're actually going to make this a static class. Now this class is going to need a few other namespaces to function the way we want it to. So we're going to add using system, and that's because we're actually going to add a second class to this file that's going to be serializable, and the serializable attribute is inside system. We're going to be using system.runtime.serialization.formatters.binary. If you can bear with that one. And this is what gets us the binary formatter. And then lastly, we're going to be using system.io, which will be familiar if you've seen the XML video. It's basically what lets us open files. It's the equivalent of the, open and save dialog windows that you have in every program, but you're doing it in code. So we can get rid of start and update because we do not have a MonoBehavior here. And we are going to create our first function in here, which is going to be called public static void save player. And we're going to pass we're actually going to pass a parameter into this. We're going to pass our player class into this, because we're kind of telling it what to save. So when we save player, first thing we need to do is open that binary formatter. And so we can do that by just saying binary formatter bf, you can name it whatever you want, equals new binary formatter. And that's all you have to do there. That one's pretty easy. Next, we want to open a file to save our class to. So we're going to say file stream equals new file stream. And the file stream, you need to tell it two things: where it's going to be saving this file and how you want to be opening it. So for the string, we are going to say application.persistent data path. Now there's actually two. If I start typing data path, you'll see there's data path and persistent data path. Data path is your asset. If you type data path, that's going to go right to the root of your assets folder, which is great for things where you want to save stuff into that assets folder. In fact, if this were some sort of like a settings file or something like that, you might actually want it in that data path. Persistent data path finds a folder in the player's program files, or when you're running this in the editor, it'll actually find a place in your files to store this, and sort of a more permanent location for it. And it's not directly tied into your program files. So this is what you're really going to want to use when you're sending stuff after a build. So when you want to have like that save data file, that's where you want to be saving it. So we're going to put this in persistent data path, and then we're going to add to that slash, so that it's putting it in that folder. And then we're going to say player.sav. You can actually make it any extension you want. You don't have to use 3 letters. You can name it whatever the heck you want. You can be kind of kitschy with it if you want, whatever. Because it's really, ultimately, it's your own file format. There's no particular program that you're trying to open up with it, like a Word doc should be DOC so that Word knows how to open it, that sort of thing. The world is your oyster. Have fun naming your files. And then we're going to say file mode.create. So now we're going to want to take some sort of a serializable class and save it into a file. Now we could just directly make this class here, take this class directly and port it right over. However, I always take issue kind of with doing that in these sorts of situations because you might have things that either you don't want to save and then you have to start marking certain things as not serializable, or things you just can't save, like say you have an image file or something that you just aren't going to be able to serialize, in which case you'd have to, find a workaround of ignoring that. So I find it's easier to just make a data class that's specifically made that you're going to put in the relevant data and then just serialize that instead of trying to work around serializing a gameplay class. So we're going to go down here outside of our save load manager, and we're going to create a new class called public class player data. And we're going to give this an attribute. We're going to call it serializable. If you don't include this using system, you can just say system.serializable, but it saves you a step to do that, especially if you've got a bunch of them. And then we are going to quickly add in here a public int array that I'm going to call stats. Now, you'll notice that in player we have 4 separate stat ints, whereas here I'm now suddenly making this into an array. And this is kind of partly to show and partly because it's a little bit more convenient just to store it in one line like that. And it's just going to show that, you have this ability to say when you're saving something, instead of needing to take it exactly as it is, you might have a more efficient way to store stuff, or you might be able to store things in a different way so that, you're making your files a little bit less heavy, or it's just going to be a little bit cleaner for you. So we're going to do that. And then I'm also going to create a public a constructor here. So we're going to say public player data, and we're going to give it whichever player we're going to be saving. And so in here what we're going to do is we're going to say stats equals new int of a size 4, because we have 4 stats here. And then we're going to say stats 0 equals player.level. I'm actually just going to copy this and paste it a few times. 1, 2, and 3. And so these will be health, attack, and defense. So now, back in our save load manager, what we can do is we can say player data equals a new player data, player data, passing in the player we have here. So now we're going to have this data object that has the relevant information for our player, and we are now going to say, not player, we're going to say bf.serialize. And first it wants to know where to serialize it, and then what you're serializing. So first, where is going to be the stream. And what are we serializing? We're serializing our data. And last but not least, you're going to say stream.close. You want to always close your files, because if you don't and you try to access them again, it's going to throw an error at you. So that's all you need to do to save the player. You make a data object, and then you just serialize it into a file. Simple as that. Loading is a little bit more complex, but still not that bad. We're going to say public static void load player. No parameters here because it's going to be giving us. Actually, you know what? We're not going to say void. We're going to say an array of ints. We're going to get back the data's array of ints when we load this player, and I'll show you why when we get back to our player class. So here, what we're going to do. First thing we want to do is, when we want to load a file, we want to make sure that file exists first. Otherwise, it's going to be a problem for the program and throw an error at us. So we're going to say if file.exists, and what file? Well, the same file that we put up here. So I'm just going to copy and paste this in. If that file exists, then we can actually start doing the same 2 things that we did here. We can actually copy and paste all of these right into here. The only difference is, instead of creating that file, we're going to open that file, which is again why we wanted to make sure it exists first. From there, we're going to say player data equals bf.deserialize, and for this you just need to give it that stream. However, you do also want to then say, right now, if this just deserializes it, it creates an object, but it doesn't know what kind of object it is. You need to actually specifically cast it either by saying as player data, or you could, at the very start here, put player data in parentheses, but I like doing the as system. There are people that claim that one is faster than the other. I just like using as. It's a little bit more deliberate, I think. Next, we're going to make sure we close that stream. And then we're going to return data.stats, because that is returning this int array so that we're fulfilling this promise we made up here that we're going to give out an int array at the end. So why are we doing that? Is because the last thing we need to do here, if we look in here, we have these two buttons, save and load. And unfortunately, with Unity's UI system with buttons, you can't actually access a static class in the button reactions. So what we have to do here is I have to give it something with a mono behavior. So I'm going to give it this player script. So I'm going to say save. Oops. Scroll back down here. This object is going to be this player info object. So it has our player script access. It doesn't have the function we want yet, but I'm going to do the same thing for the load as well. Oops. I'm going to add that in first, and then player info goes in there. So what function are we going to give it? We're going to give it two simple functions. The first one is going to be called public save. No, not save load manager. Oh, void save. And all this one's going to do is say save load manager dot save player, and we're going to pass in literally this player. Public void load is going to load that int array for us. So we're going to say int array loaded stats equals save load manager dot load player. And then we can say loaded stats, or we can say, sorry, level equals loaded stats 0. Health is loaded stats 1. Attack is loaded stats 2. And defense is loaded stats 3. So now what we'll see here, and one other thing I just need to do is I'm going to quickly say player display dot, what did I have that called? Yeah, it should be update display. Yeah, there we go. Okay. And that, again, this is just for my UI purposes. So now, when I come in here, I can hit play. Oh, I've got an error somewhere. Object reference is required to access non-static member. Oh. I need to say get component player display. Sorry, this is my own housekeeping that I should have done beforehand. Paths return a value. Oh. So we did this here and we're returning our data stats if the file exists. However, if the file doesn't exist, we need to return something. So what I'm just going to do here is I'm going to throw a quick debug.log error. If we're saying else, so if the file does not exist, we're going to tell ourselves file does not exist. And then we're going to simply return a new int size 4. So that's just going to be for int 0000. instead of the actual data that we want. So now we can go back here. Should hopefully have all of our errors gone. Hit play. First thing we can try to do is try to load. And if we hit load, oh, we also have to tell our buttons what they're supposed to do now. So save, it's going to go player, save, player, save, and load, it's going to say player, load. One last time now, we're going to save that, hit play. Now first we'll try to load this. We haven't saved anything yet. There are no save files in our system right now. Hit load, and we see field color not found in player class player data. That's a little bizarre. Oh, I think I know why that is. I was messing around with this before. As I told you, things like colors and vector3s can't be found. And so I had saved this, and I think it did end up saving into my persistent data file path. So I actually do have a loaded file. What this would normally do if you don't have a file is it would come up saying file does not exist, and it would just make all of these into zeros. What I'm going to have to do is I'm actually going to have to save this, just simply save this over with our new file again. So save. Now I can try and change this out. Let's say I change this up to health of 30, but now remember I saved it when it was back at 20, so if I load this, it should go back to our 20. And sure enough, it does. Or I could say, say we were playing our game, our guy goes up to level 5, he's got 35 health now, 10 attack, but only 1 defense because he's really min-maxing his character. Save his character. Now what we can do is we can stop playing, go about our day, come back at the end of the day, go, oh, I want to play again, load up that character again, and sure enough, 5, 35, 10, 1 comes right back. So we are very efficiently, we're saving our all of this information into that custom file that we made that really at this moment just has these 4 stats, this level, health, attack, and defense stored in an array. But really, as you can see, this is much more extensible than this. You can save a lot of different data. You can have, Booleans in terms of whether certain enemies have been defeated. You can keep counts of, how many of something has been done or how long a player has been playing. All that kind of information stored into this kind of a custom file. It's very difficult for someone to get into and mess with, and really is great for being able to save your players' progress in your games. So I hope you found this informative. Feel free to check out the other videos in this series if you haven't already. And let me know what other videos you'd like to see in the future. Thanks so much for watching. See you next time.